Hello everyone, my name is Andrea, and in this video I'm going to show you how to use the SymPy library for solving numerically and symbolically different mathematical expressions and equations or inequalities and so on, functions and so on. I think that SymPy is a really powerful and useful library since it allows you solving in a very quick and immediate way, let's say, equations, systems of equations, and so on. So, supposing that you are in the middle of your code or you're just doing some mathematical stuff and math related stuff, and you have to obtain the solution of an equation really fast to go on with your code or with your whatever you're doing. And yeah, instead of doing it by hand because maybe the equation is too hard to do to be done by hand, or to instead of looking online for an online solver, you can just use your SymPy library, type in some very easy functions, and obtain the solution of your desired equation. So just to begin, I mean, this article will be divided in different sections, and in the different sections I will show you different functions of SymPy. The first thing to do is to import SymPy. Of course, SymPy is not pre-installed, and so you have to install the package if you have still to do it. It's very easy. You just type in your terminal here, pip install SymPy, and you will have installed the package. Once you have installed it, we can import it. And since I'll be using different SymPy functions, I'll import all the functions contained within the SymPy library. So I'll just type from SymPy import, and I will place an asterisk. And with the asterisk, I'm referring to all the function contained within SymPy. So the first thing that we are going to learn is how to define and initialize a variable. So let's say initializing, let's say, two variables. Sorry. Perfect. So to do that, we use a specific SymPy function which is called symbols. We can just have to define a variable, x for example, and use the function symbols, which takes as input the name, a string, which corresponds to the name of the variable. So in this case, x, and we can do it the same with y. Y. Okay, so if we now check the type of these variables, I will just check it for x since they are the same. You will see that they have been defined as SymPy symbols, and so every time we use throughout our script the x or the y letters, SymPy knows that basically we are referring to variables. The next thing that we are going to do is to define a function, which is a very similar task. So let's say initialize a function. It's very similar. The only thing that changes is the function itself that is used. So let's call it f, and the function is called function. And again, it takes as input the string corresponding to the name of the function, so f. And again, if I check the type corresponding to f, I get that this is a function. Perfect. So another very useful feature of SymPy is the possibility to use it directly in your terminal. And as you will see, when using SymPy on your terminal, the graphical output of the results is even improved compared to the ones that you have here in your normal code. So for this reason, I'll just switch to the terminal from now on, but this doesn't mean that the function that I will show you cannot be written in your normal code in your script. They will be working as well, but the graphical output will be a little bit less immediate and let's say also less fancy. So yeah, I can just delete the print command. I'll switch to the terminal here. Let's make it a little bit more higher. So the first thing that we have to do is to import SymPy in our terminal. Now what we have to do, so I have to, oh yes, that was the problem. I have to go out from this directory and just use the Python terminal. So Python, now I'm in the Python directory. So the first thing to do, as I was saying, is to import SymPy. That is it. The next command that we'll use is this one, sympy.init_session. And as you will see, the results is, well, it's quite a lot of things. We basically initiated a SymPy session, and within this session, basically what Python did was to firstly initialize 4 different variables, x, y, z, and t, without that we had to do anything. The same other 3 parameters defined as symbols, but they are integer parameters now, and also 3 different functions, class function. So f, g, and h will be used as function. So now basically we have initiated a SymPy function, SymPy session. Sorry, we already have some variables, some parameters, and some functions. Of course, if we need to define other variables or function, we could do it in the same way. So for example, I don't know, f, g, and h are already function. I can go with l equal function and l. And so L will be a function. Let's see, type L. Yeah, it's a function. Perfect. So now let's move on. Now that we did all these things, we are ready for the first feature of SymPy. In this first example, I'll show you how to use SymPy for manipulating mathematical expressions. More precisely, how to expand and to simplify mathematical expressions. So for example, let's see this. For example, let's suppose we have a function. So f is a function, so I can use it. F equal to, and I'll define just a mathematical expression. So 3 times x plus 5 times y, and let's say minus 6, and let's square it. So this is f. We can use in order to, if we suppose we want to expand this function to see how it looks like one, we have performed all the calculation. So in this time, for example, is a square of 3 different items, which can be a lot of work sometimes. We just have to use the command expand and give it as input the function f, or we could also just have typed in the actual function, so expand f, and that is it. As you can see, now we have the expanded expression. And as you will see, as you can see, it is printed in a more immediate graphical way. We have the exponents in the apices of the letters of the variables, and also we do not have the asterisk as a symbol for the multiplication, but we have the dot, which is definitely better. So this was the first function. As I told you before, now suppose we are interested in simplifying a mathematical expression, which is a common operation that we often need to do. We can just, for this, just define another function, g, and let's say that g is equal to x to the power of 3 plus y cube plus, let's see, yeah, let's go with this, times x times y squared plus 3 times x squared times y. So this is g. Now if we want to look how it looks like once it's simplified, we just use the function factor and type in the function, so g, and this is it. All this expression was just the cube of x plus y. So in this way we have just seen how to expand and how to simplify mathematical expression. Let's switch to the next function, always in SymPy. The next function that we will see is the function solve, which can be used to solve equations and inequalities, both from numerically and also symbolically. So let's see how it works. Basically, we can again type a function, so f equal to, let's say, 2 times x plus 3. So this is x, this f, sorry. And if we want to solve this equation, suppose we want to solve, we just have to type solve f, and we have the answer. Of course, if we are not specifying anything here, it means that basically the function, so 2 times x plus 3 will be equal to 0. We could also have done it in this way, solve 2 times x plus 3, and again the result is the same. This was an example of a numerical solution of an equation, but as I told you, we can also solve the equations symbolically. So suppose we have two variables equation, and we want to solve it for one of the two variables. So we just type solve, and I will place in the equation. So 2 times x plus 3 minus y. Of course, it's if we don't specify anything, it means that this is equal to 0, and then we can just type comma and specify the variables for which we want to solve the equation. So in this case, let's see y. Let's see how it looks like, and this is it. So y will be equal to 2 times x plus 3, as it is in here. So perfect. We have both solved the equation numerically and also symbolically. Okay, so both of the two examples that I just showed you were just linear equations, but of course SymPy can be used also to solve equations with a higher degree. So for example, let's see how it works with a third order equation. So I'll solve, I'll just type x cube minus 7 times x. Yeah, that's it. Let's see And these are the solution. As you can see again, the graphical output is much better than the ones that you will get in the script. So for example, well, we can just also try to do it here just to see how it looks like. So for example, print solve, and I'll just x 3 minus 7 times x. Okay, let's see if it gets compiled. Yeah, as you can see, the result is the same, but you get square root of 7 instead of the graphical appearance that you have here, which is, I think, much better. Okay, so equations with a higher degree compared to 1. Then we can go also with the inequalities in the same exact way. So solve, let's go with x, for example, plus 4 times y minus 7. Let's see, this time we have to specify the sign, so greater or lower than. I'll be greater than 0, for example, and I'll specify, yeah, let's try to solve it symbolically. So y, and there's the result. As you can see, also the fractions are much better in this way, so y greater than this expression here. Perfect. Also with these functions we are basically done. Of course, we can also have had higher order inequalities. I can try, I don't know what it will looks like, but let's see, x squared, for example, see if it works. Yeah, and this is the solution. It was quite simple in this case. So perfect. Let's now move on to the other function, which is the last for this video. So we have seen how to solve, simplify or expand mathematical expressions. We have just seen how to solve equations of any degree, how to solve them numerically, how to solve them symbolically, how to solve inequalities in both a numerical and symbolical way. Now we can also use SymPy to solve systems of equations or inequalities in a very similar way to the one that we have just seen here. We will still be using the function solve, but this time what changes is the input of the function. So for example, we can solve a system. Let's start with the system of equation. We will have 3 equations. So solve, I'll pass them in this way, or well, let's type them directly in the function. So what changes from solving just one equation is that now we have to type in multiple equations, and to do that we will enter the different equations of the system as element of a list. So basically we just have to define a list here, so square brackets, and type in the different equations. So the first one is x plus 2 times y minus 5 times z. This is the first equation. Of course, it is assumed that it is equal to 0, so the only thing that you have to do is just to move all your elements of your equation from one side, so in order to have it equal to 0, and then you have to just type it in the terminal. So this was the first one. Let's go with the second one, z plus 3 minus x. And let's go with the third one. The third one can be y plus x plus z. And now we're finished basically. We just have to close the brackets. So this is our list that contains in each element of the list is an equation of our system. And then close the brackets again, and we will get the 3 solutions for x, for y, and for z. that's what it is. It's really easy and simple and immediate. Another thing that we can do, we can also solve systems of inequalities, which are really complicated to solve by hands. Again, we can just have to use the function solve, define a list of inequalities this time. We can just also try to go with higher order inequalities. So for example, x squared plus 2 times x. Yeah, we can also specify something not 0. So let's see, greater than 2, for example. It works in the same way. 4 times x plus 5 lower than 6. And this is the second equation. Yeah, let's go just for a system of two inequalities. Sorry, they're not equation. Let's see if you can solve it. Of course. And as you can see, you get also the expression for the infinite. So it uses the Boolean expressions to describe the solution. So basically, x greater than minus infinite and x lower than this number here. As I told you again, we could have done it in our in our script here, but the output of the solution will be worse. I can try just to show you how it looks like. Let's see if I can just copy paste here. Yes, of course. Let's see. Here again. As you can see, the infinite is represented by 2O, and this is the same if you were to just type it in your terminal. You have to make 2 lowercase letter o, and then you do not have the Boolean operator, but you just have the end, and then again the square root is just sqrt. But that's fine. I mean, the result is the same. I find it better in the terminal because it's more immediate, and yeah, it's more practical to at least to my experience. So that was it for this video. It was shorter than the others. In the next one, maybe we'll cover other functions, more advanced mathematical functions that can be used within the SymPy library to solve other mathematical expressions. Hope you will find it useful, and yeah, see you in the next video. Bye bye.